Our goal today is to take what you already know about your sine and cosine curve, the parent function, and graph different variations of it. We call them transformations. There's a couple of different transformations that we have. You can reflect something. You can move something called a translation. All right, you can move it left and right or up and down. We can also stretch it. We can stretch it horizontally. We're not going to do those, but you can also stretch it vertically. We will be doing some of those, okay? So that's where we're headed with this. And I wanna just point out and remind us of our parent function. Now this is measured, I told you there were two ways of measuring angles. This is in radians, but it's the best picture I could get. All right, so this is 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees. Okay? So that's these marks right here. So let's run through this first of all with sine. Okay? If y is sine of x, okay, what is the sine of 0? 0. And at 90, sine is 1. At 180, sine equals
2.
No.
0.
Remember, sine never goes above 1.
The 0.
So it's back down to 0 at 180.
And then it goes down to
Sine curve, yes. At 270, we're down at -1. And at 360, we are at 0 again. Okay? We've completed one full period of the sine curve in that 360 degrees. Okay? This is, those 5 points right there, you got to really know. Okay? Because as we move everything around, we're going to use those same 5 points as kind of our reference points. Okay? So every 90 degrees, you're starting at 0, then you're going up to the top, then back to 0, then down to the bottom, -1, then back to 0 for sine. Now cosine, if y equals cosine of x, cosine of 0 is 1. Okay, cosine of 90 is 0. 180, -1. And at 270, cosine is 0. And at 360, +1. Okay. So here is our cosine curve. Okay?
Cosines are always so difficult.
If you know
So
your
special.
unit circle, remember cosine is your x coordinate. So it starts at 1 and then goes to 0. It starts at 1, goes to 0, -1, 0, back to +1.
Yeah.
Okay? You just remember your x coordinates. That's why we learned the unit circle. Okay? But I want to show you these equations here. You see here this a, b, and c, and d that are in these two functions. Okay?
50 points.
What's that?
This quiz was 50 points.
All right, so we have these two forms here. The key things that we're going to look at are the a, the c, and the d. Okay? We are not going to look at b changing at all. Okay? A impacts the amplitude. We looked at this just briefly on Monday. Okay? C impacts our horizontal shift. Now the thing with C is, notice it's x minus c. So whatever number you see in here, you're going to want to go the opposite direction. Okay? You're going to see a +2 and want to go 2 units to the right, when really a +2 makes you go 2 units to the left. So the left and right is kind of the opposite of what you see in the equation. And then you have this +d. The d is, this one's easy, it is exactly what you see. So if you see a +2, it goes up 2. If you see a -2, it goes down 2. Alright? Also, the only other thing is that you might see is if you see a negative right in front of the A, that's going to flip it down below the x-axis. Okay, so instead of starting at positive 1, cosine would start at negative 1 and start going up first. Okay, sine, instead of starting at 0 and going upward, it's going to start at 0 and go downward first. Okay?
Wait.
That's only if you see a negative in front of this. Okay? Let's work through a couple and try to see some of these.
Yeah, but why would we
I
ever
think it'll
use
make
that?
sense.
I don't like. I'm so confused. Well, like, there's 3 different variables.
Yeah. So that's why we're going to take each one at a time.
So what? Like, where are you gonna find the B and the C if there's only an A?
Well, if you don't see anything being subtracted from x, then it's not moved horizontally at all. Okay? For example, here, we have 3 cosine of x. Notice nothing is being subtracted from the x, and there's nothing added on to the end. So this one has not been shifted left or right or up or down at all. Okay? In this case here, 3 is being multiplied by the cosine. So what that means is all of the y coordinates get multiplied by 3. So guess what? Instead of going up to 1, now your graph is going to go up to 3. And instead of going down to negative 1, now your graph is going to go down to negative 3. Okay? So that's why you can see right here, this choice right here, notice we're going all the way up to 3, and we're going all the way down to negative 3 on our graph. So that is 3 cosine of x. The other reason why we can tell it's cosine is because notice it's starting here at the top. It's not starting at 0. Okay? Now, we also have here negative sine of x. So what did I tell you the negative did to our graph?
It flipped it.
It flipped it, okay? So sine normally starts at what point?
0.
At 0, 0. And it normally starts going up to 1. So if we have negative sine, it's going to start at 0, 0, and it's going to go down first, okay? So, you can see right here, okay, it starts at 0, 0, and it goes down, okay? But notice also this one starts at 0, 0, and goes down, okay? So how do we tell the difference between these?
One is going down to 1/2.
Okay, one's only going down to 1/2, the other one goes all the way down to negative 1. Okay? So which one is this?
The top one.
It's the top one. Okay? It's the top one. Okay? Notice the amplitude. Remember we said the amplitude is how far away from the middle it goes? It's going down 1 and up 1. The amplitude is staying 1. Okay? This last one here, notice it's reflected, but also the amplitude is cut in half. Alright, so the amplitude is only 1/2. And you'll see here, if we look closely at this graph, okay, we're only going down to 1/2 and we're going up to 1/2. So we've got an amplitude of 1/2. Okay? Does that make sense? Right now we aren't shifting these at all. We're just stretching them or compressing them vertically. Okay? Alright. Now, let's identify what's going on with these. Alright? Here we see sine of x plus 3. Now, if you don't see parentheses, you can assume that just the x is inside the sine there. Okay? So, remember our form. It was a times the sine. We're not going to deal with b at all, so we'll just do x minus c. Oops. C plus D. Okay? So, what is, yeah, go quickly. What is happening here? What kind of a transformation is this plus 3 doing? It's going up 3, okay? It's going up 3. So guess what? All of the points on your parent function, 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. The y coordinates, you just add 3 to all of them. So instead of starting at 0, 0, we're going to start at 0, 3. Okay? This whole thing is shifted up 3 units. Okay? Now, let's real quickly sketch what that would look like. Okay. Should do this. Now, I'm still going to have, I haven't moved it horizontally at all. So my 0, 90, 180, 270, and 360 are all the same. Okay? So here's 0, 90, 180, 270, 360. Okay? However, instead of starting at 0, 0, I'm going to shift that point 0, 0 up 3 spaces. So 1, 2, 3. And there's a point. Now, let me just give you a tip here. One thing that'll make it easier for you to sketch is if you shift it up or down, I like to put a little dotted line across here. Okay? Because that'll show me what the middle is. Alright? The middle isn't going to be the x-axis anymore. The middle is going to be that line y equals 3. Okay? So, what's the amplitude for this one?
1.
It's still just 1. Okay? There's nothing multiplied outside of the sign, so it's still just 1. So, at 90, I'm going to go up 1 unit from where I started. I started at 3. I'm going to go up to 4 at 90 and put a point there. Then at 180, we're back down on the middle. Okay? So it's 183. At 270,
2.
it's going to be down at the bottom of my amplitude at 2. And then at 360,
Not 3.
we're back up to 3. So guess what? Here is my y equals sine of x plus 3. Okay? So, once you move them around, sketching them can be a little bit challenging. Okay? But if you know your parent function, you know those 5 points real well, it's not too bad. Okay? We won't sketch all 4 of these or all 3 of these ones, but let's at least identify the transformation. What's happening here with f of x is cosine of x minus 4?
It's going down 4.
Down 4? Do you guys agree with that?
Yeah.
Think so? Okay. Notice it's not in the parentheses with the x inside the cosine. That would be a horizontal movement. Alright? So it is shifting down 4. Okay? Sorry, I forgot my pencil, so I can't write really, really neatly. Okay. Alright, and then we have our last one here. The last one. We see 2 different things going on here, okay? So someone give me one of those things. What's happening to our parent function?
Going up to.
It's going to shift up 2. Very good. This tells us we're going to go up 2. And then what does the other 2 tell us?
The amplitude?
That's right. It tells us the amplitude. The amplitude is 2.
I want to go to meet. What's the
Yeah,
amplitude?
what does the amplitude do though? Oh, it's just.
Just gonna make it go up to. Down to.
Oh, so it multiplies, so like if it's. Wait. so if it's at 90 for like sine, and it's amplitude 2, like on that example, like if it's just like 2 sine, would it go up to, instead of at 1, it would go to 2?
Yes,
And
that's
then it
right.
would go down 2, and then down another 2.
That's exactly right, okay? So like this one here, it's gonna start at 0, 2. Okay, I'll graph it on here. And I'll put my little dotted line so we can see where the middle is. Okay? Now watch. Instead of at 90 going up just 1 unit,
Go 2.
it's got to go up 2 units. So it's actually going to end up in the same point, up here at 94. Okay? Then we're back down to the middle by 180. And then at 270, where is it going to be?
0.
It's going to be at 0. It's going to go down to, again, because our amplitude is 2. So there we've got, it still looks like a sine curve. It still looks the same. It's just stretched vertically now. Okay? We've stretched it out vertically by making our amplitude 2. Okay? Pi is just a number, alright? So just treat it like any other number. But here's one that has 3 transformations. Take a look at it and see if you can identify all 3. Alright, Nolan, what's one of the transformations?
It's gonna go up 4.
Alright, what tells us it's going up 4?
Plus 4.
Alright, the plus 4, that tells us it's going up 4.
units.
Okay? Carlotta, can you tell us another one?
I would say x minus 120.
I'm sorry, what?
No, I don't know.
Do you know what the 2 would tell us to do?
Yeah. Oh, are we on the right page? Yeah, no, I'm on the right page, but
Someone help us out?
It's
Chris?
the amplitude, right?
Okay, yeah. The amplitude would be 2. That number in front that's multiplied by the trig function, that tells us our amplitude. So amplitude equals 2. And then how about this plus pi over 3? What's that going to do for us?
It's gonna shift to the left.
To the left,
Is the
okay?
plus-
It's going to go to the left,
Pi over 3.
whatever pi over 3 is. Okay? Now, we aren't using ratings in this class, but it's just another number, so it's pi over 3. Okay, I won't have you sketch ones like that, but here's what I was telling you, though, about it seems like it's kind of the opposite of what you might think, because plus, you might want to go positive on the x-axis, but it actually goes the opposite. It goes to the left. Okay? Alright. Here's a couple others. Let's just try to run through these real quick. I just want to really drive these home in your heads. Okay? So, let's see. James, what's happening on this first one?
It's going over 1.
Let's go.
Which direction are you talking about?
Nope. No, right.
I couldn't hear what you said first. Left? Okay, how much?
1. Nope.
Well, just
It does it, I don't
pi.
know.
Okay?
I don't know what pi means.
It's just pi.
3.14.
It's just a number.
Oh,
Okay.
Does it go to the right then?
Is it like 3.1?
No, it goes to the left.
7, 8, 9?
Remember our form said x minus c. So you could think of this as x minus a negative. Alright, that's why it's going to the left.
I also have a question. You
Yes.
say going to the left, but what if there was a plus, like let's say a plus pi, like outside of the parentheses? Would that mean left pi and right pi should they nullify each other or what?
No. If we're adding something outside of the parentheses, what does that do?
Doesn't it shift it
It shifts it, but how?
horizontally? No. Up or down?
Up or down? Up or down, okay? So that plus 1 right there,
Stretch.
no. Stretching has to be multiplication. That's the that's if you see a number in front like that. Okay? if you see something being added outside of the parentheses, that's gonna be the vertical shift. It's gonna move everything up or down. In this case, up 1.
Yeah, so the pi would be, be left.
Okay, in here, yeah, it's a left pi over 2. Okay? How about this second one? Cosine of x minus 120.
So we go right,
Go to the right ones, please.
Yeah, that's right. It goes to the right
You want some-
How about the last one?
120 degrees.
The last one, the one. How about
the last
the
one,
last
what you propose?
You need that.
The last
How about the last one?
What about the last one, Owen?
There you go, good.
Up,
Left,
450. That's about right, right?
left 45, okay? Left 45. Again, if you see addition inside the parentheses, it's the opposite. You're going to the left, okay?
Oh. No, you do this thing like.
Alright, so
I was thinking-
here's where you gotta think a bit, okay? I want you guys to take a couple minutes here and try to sketch the graph of cosine of x plus 90 plus 2. So identify the two transformations first, okay? And then try to actually sketch what it looks like. Alright, first thing you've gotta do is identify the transformations, okay?
Yeah, we're gonna be left.
So, it's left 90,
And up 2. Stop, it's my charger.
okay, left 90, up 2. Let's start with this, okay? Normally, when you're shifting, you know how I said give yourself that horizontal line if it shifts up?
Yeah.
Okay? This is shifted up 2, so I'm going to give ourselves this horizontal line up 2. Okay? But I'm starting at negative 90. Okay? So negative 90 is over here. Notice how I put that little crosshair there? That's kind of like where the origin would get moved. Okay? The origin gets moved to the left 90 and up 2 units. So from there, cosine starts at the top of the amplitude, right? It normally starts at 1. So if I'm already here at 2, where is cosine going to start?
3.
It's going to start up at 3. Okay? So right there is one of the points on our cosine graph.
But is that like the first point, is that like 0? Or like what?
That's where, like, the original function looked like this. Okay? Here's our original cosine function. Okay?
Okay.
So this point here got shifted to the left 90 degrees and up 2.
Mhm.
If it helps you to draw the original one and just move each point individually, you can do that.
So then, I don't know.
Okay? So now, this point here at 90, 0, needs shifted to the left 90 degrees and up 2. Okay? So now it's at 0, 2. Okay? And you should fill this in your own, in the handout I gave you so you can know what's going on later. Okay? So now, I have this point at 180, negative 1. So if I shift it to the left, it's now at 90. And then I shift it up to 1. Okay? So it's at the point 91.
Okay.
You getting the hang of it now?
So you're just basically taking a regular cosine graph and you're just doing the shifts like from those points.
Yeah. If you know those 5 points, then the shifting, you just take each one and you can shift each one individually. Okay? So 270 is now 182. And 361 is now 273. And there is our cosine curve.
God bless.
Okay? Does that make sense?
And do we?
Pretty much?
Oh no.
A little bit?
Yes.
Okay. Alright. So, what I want you to do for tomorrow, I want you to try, okay? The last two here, you're trying to write an equation. So you need to identify the transformation. Okay? Now watch this. I'll give you a little bit of help with this last one. Try to pick a starting point. Okay? So right there is a starting point. This one is going through the starting point, so I know I'm going to use which one? Sine or cosine? Which one starts on the, huh?
Cosine?
Sine.
Which one starts at 0?
Sine.
Sine.
Sine, okay? So this is going to be a sine. Then look at your amplitude. Is it still 1 or did it change? Okay? And then look, is it moved horizontally or is it moved up and down?
Both.
Okay? Is this one moved horizontally?
Yeah.
How far?
I think
On one side to the other.
Two.
Oh wait, forever.
This is
It
crazy.
goes on forever.
Wait, what?
Oh,
Negative
shoot.
Okay, it's moved vertically -2.
But it goes side
We're
to side
still on the
forever.
y-axis, so it hasn't been shifted horizontally at all.
So just for
it is sine x minus 2.
So the
That's
last-
exactly right.
It goes
Sine of x minus 2. The whole thing has just been shifted down 2 spaces, and that's it.
So for those, you just have to like make your own equation for it.
Exactly, okay? So there's one to graph, one to write an equation for tomorrow, okay? Alright, see you guys. These last 3.